everyone. Today we are going to learn about the proximity switch. First, let's learn what a proximity switch is. A proximity sensor is a device with the ability to sense the approach of an object. The approach of the object is recognized by the characteristic of the proximity sensor sensitive to the object being approached, and then the corresponding signal is output. Proximity sensors are usually called proximity switches, also known as non-contact travel switches. In addition to stroke control and limit protection, it is also a non-contact detection device, which is used for part dimension detection and velocity measurement, and can also be used for frequency conversion counters, frequency conversion pulse generators, page control, and automatic connection of processing programs, etc. It is characterized by reliable operation, long service life, low power consumption, high precision of multiple positioning, high operating frequency, and adaptability to harsh working conditions. In this lesson, we are studying the photoelectric proximity switch. Photoelectric sensors, also known as photoelectric switches, use light sources as media and apply photoelectric effects. When the light sources are shielded by objects or reflection, radiate, and shade occurs, the amount of light received will change so as to detect the existence, size, and brightness of objects. It is a switching element that outputs signals to contacts and non-contacts. The photoelectric switch is equipped with a light source, and the emitted light source is used to detect the variations in the reflected, absorbed, and transmitted light of the detected object. Commonly used light sources are ultraviolet light, visible light, infrared light, and other wavelengths, and the forms of light sources include bulbs, LEDs, laser tubes, etc. The output signal includes switching value or analog value and communication data information. After that, we will learn the characteristics of proximity switches. The proximity switch has the following characteristics. Since it can conduct detection in a non-contact manner without the need to physically contact the detected object, no wear-in damage is made to the detected object, thus extending its service life, except for the magnetic types. The use of semiconductor output has no impact on the life of the node. Different from the light detection, it is suitable for environments when water and oil exist. It is almost unaffected by the stains, oil, water, and etc. in the detection object during detection. It can detect almost all objects. Compared with the contact switch, because the light itself is high speed and the circuit of the sensor is composed of electronic parts, mechanical working time are not included, and the response is super fast. Next, we will study the application of proximity switches. Proximity switches are widely used in aerospace technology and industrial production. In daily life, it is used in hotels and restaurants, automatic doors in garages, automatic hot air machines. In terms of security and anti-theft, such as data files, accounting, finance, museums, vaults, and other important places are usually equipped with anti-theft devices composed of various proximity switches. In terms of measurement, such as length, position measurement, and control, such as the measurement and control of displacement, speed, and acceleration, a large number of proximity switches are also used. There are many kinds of proximity switches, having various applications. Their shapes and structures are even more diverse. The figure shows the structure of some proximity switches. Finally, let's learn about the types of proximity switches. According to the detection mode, photoelectric switches can be divided into three types: opposite, reflective type, and specular reflection type. The working distance of the reflective type is limited to the intersection point of the beam to avoid the influence of the background. The specular reflection type has a long reflection distance, so it is suitable for long-distance detection. Additionally, it can be also used for detecting transparent or translucent objects. The first one is the opposite type proximity switch, which is composed of a transmitter and a receiver, and the two are separated from each other. The second is the slot proximity switch, which integrates the transmitter and receiver, usually with a standard U-shaped structure. The third is the diffuse reflection proximity switch, which integrates the transmitter and receiver. The light emitted by the transmitter directly irradiates the detected object, and the detected object produces diffuse reflection, and the receiver changes the switch state according to the change of the reflected light. The fourth is the specular reflection proximity switch, which is also a photoelectric switch that integrates the transmitter and receiver. It has a multi-edge mirror compared with the diffuse reflection type. The fifth is limited emission proximity switches. It integrates the transmitter and the receiver and forms an angle between the transmitter and the receiver, and the sensitivity is the best in the cross area between the transmitter optical axis and the receiving optical axis. It is used for fine detection, such as marker detection. The sixth is the optical fiber proximity switch. Optical fiber is also known as light guide fiber. Optical fiber photoelectric switches use plastic or glass optical fiber sensors to guide light, and to realize the detection when the detected object is not in close areas. Usually, optical fiber sensors are also divided into opposite beam and diffuse reflection type. In this lesson, we learned about the characteristics, application, and types of proximity switches. You can consult the information after class to learn about the applications of proximity switches in life.